From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Identifying challenges and solving those challenges. And that was actually, that's a fun part of research, don't get me wrong, but, that's not what the engineers that wanted to use the product really cared about. They didn't care about too much what our journey with the research was. They really cared about the results, right? And I think what it came to is the cultural part of convincing lots of engineers who've been doing things a certain way for a long time to try something new.
That was Steven Floyd. Steven is an experienced engineering and technology leader focused on advancing additive and advanced manufacturing. He is CEO and Chief Engineer of Floyd Technology Consulting, where he helps organizations accelerate innovation and adoption of cutting-edge manufacturing technologies. Prior to that, Steven led additive manufacturing technology development at Northrop Grumman, driving multidisciplinary teams to deliver AM solutions across aerospace and defense applications, including polymer, composite, ceramic, and metal technologies. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or data management support around additive, reach out to our team through our website or via email at info@3degreescompany.com.
All right, Steven, thank you so much for joining the show today. Excited for conversation. This has been one long in the making. So like we do with most of our guests, I'd like to start at the beginning. So where were you born? Where'd you grow up? Let's just start there.
Yeah, so I grew up in Northern California, in kind of wine country, Sonoma County area. So lots of oak trees, lots of vineyards, nice nature, a lot of hiking and fun outdoor activities, and but also close to the Bay Area city environment. So it's kind of where I grew up through high school and had a lot of fun as a kid.
Yeah. Did you do you have a seminal memory of engineering or taking things apart or even materials that kind of helped put you on the path of where you are today?
I think sort of what drove me into aerospace engineering actually was sort of a teacher I had in roughly middle school who was a former aerospace engineer and went back to teaching, middle school in this relatively small town I was in. And I was just amazed by some of the stuff he told me, some of the stories he told me about some of the really cool aircraft he got to work on. And my mind was sort of blown. And I was like, that sounds really cool. I think I want to be a part of that someday. And, I always really enjoyed math, but it wasn't until I kind of met him and found that connection that it became clear that I could do a really cool job that not just involved math, but got to do something as fun as work on spacecraft or aircraft. So I think that decision happened pretty quickly for me and I never really looked back.
What was it that excited you about it?
I think it was just the challenge of it, the interesting nature of it. To me, it just really seemed incredible. And I was like, that sounds so fun. Like I could spend a lot of time doing that and never get bored with it.
Yeah. And so, that led you kind of to your degree, but like, as you were doing it, like, was it what you expected?
I think it mostly was, like college. I think that you go in there with a certain expectation of, everything's going to be amazing. Everybody's going to, want to do exactly the same thing. But I think you realize, no, everybody brings a lot of different perspectives to the table. And some people are more interested in, certain topics and people's approach to studying and just their own mentality, how they process the information. And I think that was what was more interesting to me, because you find a lot of people who are like-minded as far as what their sort of career aspirations are, right? Or studying the same topics, but they have their approach to how they do it and what they bring to the table. I think this was probably one of the more exciting parts. Plus just getting to see a whole new area, going to school in San Diego, and San Diego is a pretty cool place. So that was kind of endless fun for me, at least.
Yeah. And as you're doing that, aerospace seems to me, as a fellow engineer, I was a materials engineer, so it's one of those degrees that, like, it's very clear like the types of companies you go to, right? Like if you're a mechanical engineer, like there's a million different, like it's so opaque, right? Like that it kind of fits in anywhere. But aerospace, like a normal person off the street can say like, hey, if you're an aerospace engineer, name me 5 companies that you might go work for, right? Like people kind of know the names. But like, did you have career aspirations to go to industry, or like were you targeting a specific company or area as you were kind of doing your education?
I didn't have a specific target actually, and I think part of that was, I didn't know a lot of engineers. I didn't know anybody really in industry. So while I did well in college, it was mostly through attending career fairs and talking to some of the professors and just trying to better understand even what the jobs are, the actual jobs as an engineer, not just, oh, cool, I'm an engineer, I'm going to go work on really cool things, right? And it's no, but actually knowing, okay, there's jobs like a quality engineer, there's jobs like structural engineering and, fluids engineering and all these specific roles, right? And you kind of learn a little bit about it through the classes, but it doesn't really tell you what you actually can do in industry where, people actually have to add value to something and get paid for that value they're adding, right? So I think that was the interesting journey with respect to, what do I do after college that I went through as an undergrad. And ultimately, I got to senior year and I still didn't really know what it was I wanted to do, other than that I wanted to work in the space industry. So that really shaped my job search and narrowed the focus on at least at that time, there was no new space industry, right? It was, if you wanted to do space, you worked for a select number of large companies mostly. You didn't have a lot of segues as a college grad into opportunities unless you really knew somebody to get you into those opportunities. So for me, I quickly became targeting some of the large companies, and ultimately I landed with Northrop Grumman, and that was great. So.
Yeah. And do you remember what your first role there was? Did you kind of know going in what you were working on, or was it?
Yeah, it was exciting because there was a kind of a interview career day for people who got through an initial round of screening or so, and so they brought us on site to Redondo Beach, where you got to do interviews with various hiring managers in different kind of roles and jobs. And so I actually had 4 managers that wanted to hire me there, and so then I was left with a choice of. Okay, which
it's like The Voice, right? Like you got the 4-chair spin, and
exactly.
Yeah,
that's a great comparison. It felt exactly like that. Where like, well, you should come do this job, and I'm like, well, I don't know what that job is.
With John Legend or Blake.
Yeah, I mean, this is pre-Chat GPT days, right? So it's the earlier search engine days, right? So try to do a little research and figure out what was going to be the best fit for me. And I narrowed it down quickly to 2 of the 4, and then I was sort of left with a choice, like do the role that I knew I could handle really easily, that was more in the wheelhouse of what I had sort of learned in college, or do the one that seemed more challenging, and it was the one more related to the classes that I actually struggled with the most. And I actually chose the latter. I was like, I'd rather be challenged and try to see if I can learn this stuff. And it was a position that was going to have some research and development to it, and it was doing kind of structural dynamics and vibration suppression type of research, like isolation and damping type of stuff. So for me, that seemed really interesting, and challenging, like I said. So I went that direction. I chose that, and that brought me into my first year at Northrop, and I got to study under somebody that had decades of experience in vibration research and development and solving some of the most challenging problems that to that point Northrop had encompassed in developing spacecraft. So it was awesome getting to tutor under him for that first year.
And to the extent that you can say, I mean, when I think of Northrop Grumman, I don't necessarily think of spacecraft, but what does that mean? Is it like satellites? Is it like vehicles? Like what does, like, to the extent that you can say and not have someone knock on your door, what does that mean, spacecraft, in that context?
Yeah, spacecraft is encompassing. It includes satellites. It includes telescopes, and the most exciting one that I worked on there was, of course, the James Webb Space Telescope. So that's a great example of probably the high end of complexity and an amazing science mission behind it. Really exciting working with NASA. So I think that's the the pinnacle of the types of programs that could be considered a spacecraft, right? If working on something like that. And then of course there's, the more, you know, you know, less of a science mission and more of just doing something
Cameras that look at other things.
something like that, right? So it's and there's commercial space, of course, too, like communication satellites and things like that. And Northrop Grumman makes a lot of different space products, and some of those products are complete systems, of course, but then sometimes it's just selling other products that are smaller and go into other people's products, like commercial satellites or things like that, right? So space is somewhat encompassing, and at least where I was at, it was pretty vertically integrated in that it included everything from the microchip level, all the way up to the large structures that attach the vehicle to the rocket. So, it was a large variety of scale and a large variety of system complexity that kind of fits all in that regime of space, right?
And when did additive manufacturing come into your path?
So that was a little later. So I spent a year doing structural dynamics and kind of learning that, and then unfortunately the economy went pretty south and a lot of programs were canceled.
What year is this roughly?
This was in the 2009-ish time frame.
Yeah.
Right. So that kind of left me with kind of staring down the option of actually maybe not even getting to stay at Northrop. But fortunately, I found a path to stay. I moved over into doing structural analysis and stress analysis, as most people kind of commonly know it as in engineering circles, and that was fun. I got to learn and kind of hone that craft. Started with mostly analyzing ground support equipment, actually, which sounds okay. Well, what does that have to do with space, right? It's like, well, the ground support equipment makes sure that you can actually build and assemble the complex things that you're trying to deal with, and how you move them around and get them through different tests, and get people to be able to work on them and continue those assembly operations. Because when you're building a really complex system that's big, it's not super straightforward, like how you actually do all of those things. And so it results in a lot of custom work stands and offloading fixtures and all sorts of kind of complicated mechanical assemblies. But at the same time, it's not the really, complex system that everybody puts a lot of attention on. So I think what I enjoyed most about that is that meant it was fairly rapid pace, because everything was effectively like designed as ground support equipment, which means over-designed. Like everything was meant to move fast. It's like, okay, don't spend a lot of time analyzing the structure. We just need to make sure that it's definitely good enough, right? And so it wasn't like engineering a typical aerospace product where weight is so critical and you're trying to kind of eke out every ounce of performance you possibly can and reduce that mass as much as you can. This was more of a, well, we got to get that analyzed in 2 days and we got to move on, right? So at that point it was, all right, if in doubt, just make it stout, right? And keep going. Right? And so it was fast paced. It was fun. I got to learn a lot about how to do structural analysis, things of like analyzing welds. Learned a lot about welds that way, analyzing bolted joints, etc. And so I spent a couple of years doing that before really transitioning to more analyzing actual space hardware. And I there was some sanity to that madness that my manager put me through. That he did it intentionally, and looking back, I'm like, yeah, that was a really great way to learn like 5 to 10 years worth of stress analysis in 2 years. Right? It was a little wild, but a lot of fun.
And so, go ahead.
So that kind of led into, doing structural analysis on actual spacecraft for, a number of years. I eventually became a functional manager, which meant I was sort of managing other structural analysts. And then eventually I found my way more into the kind of technical leadership on programs and, chief engineering roles. But sort of along that journey, at one point, my manager tapped me on the shoulder and says, there's this 3D printing additive manufacturing stuff going on. Don't really know anything about it. There's folks up the street starting to do some stuff with this, but they don't have any structural analysts involved. So if we actually want to use this stuff someday, we probably should get somebody involved. So why don't you go up the street, go check out what they're doing and report back to me. And I'm like, okay, that sounds like an interesting assignment. People don't normally ask you to do that, but sure, that sounds cool. And, kind of the rest is history. Of course, I went up the street and I realized, like, wow, this is insane. Like, what are we actually trying to do with this stuff? And started supporting them a little bit, and just over.
And when you say up the street, is it like different group, different build? Like what?
Yeah,
what
at the time, Northrop Grumman sectors were organized where they had merged the aeronautics and the space sectors together into what was aerospace systems at the time. And so when I say up the street, I meant that I went, from Redondo Beach up to El Segundo, where more of the aeronautics and air people were at. And so that's more where the development was happening and the research part of this. So, and yeah, at least at that time, though, it was interesting because we had a very, very large group of structural analysts that were doing huge variety of work from, spacecraft to aircraft and all that. So that also sort of meant was that the additive team had a pretty broad look at what they were trying to do early on.
And what was that process kind of like? Was it like, hey, we have target products we think could use this, we just want to explore the technology, we need to understand the materials? What was like some of those early goals when the technology's it's somewhat early days, right? Probably early days within the company, certainly. But what was the push to really like understand it more? Was it metals? Was it polymers? Was it everything? Composites?
I mean, it was kind of everything. And the reason for that is it was really trying to drive to where could additive add value. And it wasn't just limited to, things that would fly and go with a vehicle or a product. It was also looking at where additive adds value in production. And I kind of mentioned doing ground support equipment analysis earlier. And, it's looking at things like that. How can I make these things faster? Or how can I hold things better? Or how can I, use it as tooling to make, operations more accurate, or, save time in the setups of those operations, right? And those were where a lot of the early wins for additive really were. It wasn't because, like you said, it's like we got to dig in and really understand it if we're going to use it on a vehicle. And so while there wasn't perspective of what could the technologies do as flywood products, we knew that was going to be a longer journey. And so, up front, it really was looking at where are those low hanging fruit, high value wins that will show that 3D printing can do something really interesting, even if it's not, the hardware that flies, but it's just stuff that helps us do our jobs better, faster, cheaper, right?
Yeah, and I've seen other large companies, right? They kind of take maybe similar approaches, right? Where we like, hey, we'll have like kind of a center of excellence, or we'll have our 3 or 4 people that really know additive, and we'll kind of build some case studies and kind of start it that way. But ultimately, it takes a real long time to permeate into like a common solution that a engineer or program maybe not affiliated with that group would understand. So what was it like once, like, hey, we're proving out some of these case studies? Is it like, hey, let's just double down in that space or sector? Or is it more like, hey, we need to be out in knocking on doors saying like, hey, we got this cool and interesting technology, like, hey, here's where it could be fit? Like, what was the adoption like, or kind of the ecosystem like in your experience as you start to work in the industry and start to see the results and see potential?
Yeah, I think that's actually where more of the challenge was, right? When I kind of look back at those years of trying to both help mature the technology, developing data, looking at, where things weren't really working from a quality perspective, and, feeding that back to, say, the machine OEMs or the material manufacturers, and, just working through some of those challenges. And that's just, applied research and development, right? That's, identifying challenges and solving those challenges. And that was actually, that's a fun part of research, don't get me wrong, but, that's not what the engineers that wanted to use the product really cared about. They didn't care about too much what our journey with the research was. They really cared about the results, right? And I think what it came to is the cultural part of convincing lots of engineers who've been doing things a certain way for a long time to try something new really did come to be the biggest battlefield, if you will, of trying to get additive into flight. Well, qualification and certification are extremely important, and they're the most technically challenging. Yeah, that the nuances of convincing engineers to try something new was actually far more challenging, I think, as far as finding approaches that worked and, being successful in in overcoming those barriers to adoption that are just sort of so ingrained in people. Um, yeah, and so I think it's kind of what do we do to start to overcome some of those barriers? We tried a lot of different things, and some of it was developing training resources. And one of the kind of first larger things for additive that I kind of truly led was the development of engineering resources for additive. And so it was with a team of folks, some really great folks so several of them are still at Northrop actually. And we worked together to write engineering manuals to really talk about the technologies that we had advanced the most. And so things that we had a great idea of, this is how they should be used. We had a good amount of, say, design for additive data, a lot of mechanical data and things like that, where it was a mature capability, but people needed to understand it better. And so what we ultimately did, is write what you could consider to be a kind of master's level kind of textbook with lots of details on those processes and how you use them, where you use them, what data we actually have, how you interpret that data and translate it into design. And then we ultimately developed short courses off of that deeper textbook, if you will, and started teaching engineers from that. And so that made it easier. And we really did sort of refine that workshopping, teaching approach as we went. But it always got positive feedback. And I think it actually did really help people become comfortable with trying it for the first time. And that was what we often found was the biggest challenge, was getting somebody to try it. Because once they sort of tried it, they seemed to love it most of the time. And so I'm sure you have similar experiences with additive and folks you talk to that they maybe were reluctant to give it a shot. And then they saw like, wow, this makes my design this much easier for this specific problem. And then they sort of never look back. Like suddenly they're the one telling everybody else they should be using additive. And you're like, wow, I'm really glad I trained that person, because that really actually helped drive our mission forward significantly.
And so I know you've worked on a number of platforms and materials, but do you have a something that stands out, whether it's a project, whether it's a material or process application, product application that you could talk about that kind of sticks in your mind?
Yeah, I think the most fun, and this is one where you'll find that I have patents, that I'm on the patents, some of the patents that Northrop Grumman got in it, was helping develop continuous fiber additive manufacturing. And so this is becoming a little more of a hotter topic lately, but Northrop Grumman dove into helping develop continuous fiber additive manufacturing. And I can't go into too many of the details on it, but what is available publicly, you'll see, what's called SCRAM, scalable composite robotic additive manufacturing, and it was worked on with Electroimpact. And if you don't know who they are, you can look up some YouTube videos and see what the SCRAM machine is and what it does. And but suffice it to say, I was involved with the team helping, kind of drive that capability from more of the end user perspective, and what the system had to do, and what was non-negotiable, and how we get to something that'll make the kinds of products we want to make. And what was most fun about that is, it set out with that mission from the start of, FDM's great. There's a lot you can do with it, but it's not really high performing from a material perspective, right? And the systems that we saw available were really limited to, typical 2.5D, planar layer printing. And so when it comes to something like a continuous fiber, you need to be able to put it in the directions that it's most useful in your product in 3D space. So it became very clear that if we were really going to unlock what additive can do from a material perspective in the polymer and composites realm, it was going to have to be, continuous fiber additive. And so that was something that I spent over a decade working on, and hence I'm sort of a little biased to calling it my favorite.
Awesome. And so now, I mean, you've left Northrop. You want to talk about kind of what your journey has been since then?
Yeah, and so at the time I left Northrop, I was basically multi-hatted role leading additive manufacturing for space. And so, that means some days I was chief engineer, making, important critical decisions on the technical side, and doing a lot of strategy, type of development. And some days I was that, lead trainer and, teaching a short course. And other days I was doing more of a program management type of activities and, kind of doing program reviews and stuff like that. So it was a very challenging, exciting role where at least I got to wear all these different hats and learn a lot about kind of the business and like where the real challenges with additive were and what adoption was looking at. And then the other really fun part of that role that I just really loved was working with small businesses and universities and collaborating together and figuring out how we take what they've developed and what their capabilities are and integrate them or push them in a direction that aerospace can really leverage it and take advantage of it. And so some of the fun projects included things like trying to push them specific directions to enhance capabilities, or doing demonstrations with them and targeting specific product areas and how those technologies fit those product areas and proving that it can work. Right? And so those are the types of projects I really, really enjoyed, and the relationships that I really enjoyed was working with those kind of small to medium businesses and academia, and like helping make those connections, helping bridge things together that otherwise might not come together if somebody wasn't really trying to push them together to be used for something where it can really make an impact, right? And so when I left Northrop, my motivation in calculus there is that I really wanted to keep doing that. I wanted to do more of that, right? And so that's what led me to sort of decide, I'm going to go start my own LLC, really start in the world of consulting and try to go help these businesses in ways that I couldn't when I was at Northrop Grumman. And it's been exciting so far. I have helped a couple of companies, and we can probably get into that a little bit more.
Awesome. Yeah. So excellent. So yeah, let's keep on that thread. How is that going today, and what have you learned? What are some of the initial projects you can talk about?
Of course, some of the early challenges were just figuring out how to, run my own company and, doing marketing and business development type stuff. But eventually I have helped a couple of companies. One that I announced on LinkedIn previously was working with AlphaStar Technology Solutions. They have some, interesting and really powerful tools for, it's really integrated computational materials engineering at the end of the day. More strengths and focus in polymer and composites, but also some capabilities in the metals arena too. And so they're really a software company, and they've been around for over 30 years, and they've done a lot of interesting work, a lot of really exciting projects, more in defense focus than anything, but also in aviation, commercial focus too. And so kind of just that role there has been helping them with understanding certain challenges and pushing in new directions and thinking about business strategy and technical approaches and things along those lines. And so I can't really get much deeper into it than that, but it's been a lot of fun helping them. That one's been fun too because they're more local, so I get to visit them periodically without too much difficulty. I don't have to get on an airplane, just got to drive down the freeway a little ways. The second company, I've been helping was Additive in their powder bed fusion arena. So we did some collaboration on a study they were looking at with thin wall parameter development and some of the aspects about their machine and capabilities that make it very suitable for thin walls. So I saw some of the work they were doing, and it looked really exciting. And I was like, yeah, maybe we can help you with that project you've got going on, and we'll see where we end up. And so that was fun. Of course, they're a little farther from me, so getting out there to visit them had some logistics to it, but I still managed to get out there occasionally and see them in person. And so those are kind of the first two companies I've helped, and done some other fun things too, like more outreach type stuff. I presented a seminar at Ohio State University back earlier this fall. And that was a lot of fun meeting the professors and talking about, their research and where they're going and, how I might potentially be able to collaborate with them and the university and their program. And if you haven't been to Ohio State's kind of seen Ohio State's research program, what they're doing with Additive and their additive facility, if you will, I liken it to a graduate student's like playground. If you're an additive engineer and you want to, be able to just learn everything about, metal additive and especially directed energy deposition. I've never seen a place like that. My university certainly didn't have anything like that, where students get hands-on experience with welding, and then they can also go down the hall and do metallography. It's a pretty cool place and special place, I think, for the students that are there, and you could tell how much they loved it too. So that was really exciting.
Awesome. And then kind of the latest thing that you just announced on LinkedIn is your kind of collaboration with Welders ASTM. So you want to talk about kind of the standards and kind of
absolutely.
Your approach there and what you're doing.
Yeah, so I decided to and had the opportunity, and fortunately, to join Welders Associates and start helping Welders Associates, powered by ASTM. So it's a combination of consulting projects and ASTM activities, and it seemed like a really exciting opportunity to me to kind of start to help a little bit more in one of the other areas I'm passionate about, which is kind of standards. And one of the things that became clear to me the last 5 years, and only became more and more clear, is we sort of have a cost problem with additive. That there's a lot of really great design opportunities that make a ton of sense for additive, but you get through the design and you start getting into quotes, and you come to realize, okay, it's just too expensive. Like, this should be a great additive part, but the cost doesn't make sense. And I had other instances in which people would approach a problem with additive and say, oh yeah, can we do additive for this? And you look at it and you're like, that's kind of a boring application for additive. Actually, that's probably a bad application for additive. But, they're passionate and like, well, let's just go through the motions. And every once in a while, one of those would be a great business case for additive. And it would be sort of shocking, because it'd be like, this is really not what additive was meant for. The only reason this is working is because the oddity of the economics of how many parts you can fit in the machine and how little machining it needed, or something like that. And it wasn't like a DFAM part. It was not something you would put in your brochures like, hey, look at this great additive part. It was something kind of dumb that just the economics happened to work out. And that kind of drove me to start thinking about that a lot more. Is like, why is this? Like, why do we have this cost problem where one of the benefits of additive can be the performance it unlocks in your design, but those applications aren't always the ones that make the most economic sense. Mm-hmm. And what that sort of drove me to was the focus on standards and how that really does reflect into the cost. Because we've got suppliers that are working to a lot of different companies' internal standards and trying to manage those requirements. And sometimes it doesn't always work. And everybody's trying to solve the same challenges independently, and coming up with slightly different solutions, and solutions that frankly probably aren't as good as if everybody actually worked together to solve those problems. And so I think what that has led me to realize is that some of the cost problems are related to exactly that people are doing things lots of different ways. They're not working together. Everybody's developing the same data independently and using slightly different numbers, and things as simple as 10 degrees of difference in a heat treat specification require a supplier to maintain multiple processes, right? And effectively what that ultimately means is that each person using that supplier is responsible for bearing their own cost of maintaining that supplier's certification for those standards. Plus, the supplier is managing all the paperwork and different processes and adding cost to their operations, because they have to keep everything so segregated. And right. And so there's a lot of these just silly things we're doing that I could see that we're driving up costs, right? That it's like, okay, why is it costing me this much money for post-processing? And I think that's where I quickly realized a lot of the challenge with additive cost structure is it's not the raw material or the feedstock. It's not the amount of that feedstock that goes into the part, and it's not necessarily even the machine cost most of the time, like the equipment for doing the additive. It's a lot of it's in the inspection and quality, and this post-processing of paying everything, in small quantity, kind of not batching things the way it really could be. And so the last few years, that's what drove me to really want to get more involved with standards and, bringing people together to work together to solve the challenges. And that's what, Welders Associates and ASTM really brings to the table, is that's sort of their core mission at the end of the day, is helping all sorts of industries come together better, internationally, getting people to really collaborate on, defining the best approaches to do things industrially, and developing and releasing those documents. And standards are developed on volunteer time, basically, right? So it's everybody actually just under a common mission that is developing a standard, wanting to work together because they want to see things get better, right? And for me, that was what was really exciting about that, is it tied into like I said, why isn't additive being used more? Why aren't we making more of an impact? And some of it was the standards area. So really excited to join Lawyers Associates and ASTM to start helping with some of those types of projects more. Also, it provides me a means to work with more of a team and take on bigger challenges than I could take on by myself. So I think that's for two reasons, both in that standards arena and the ability to make a bigger impact with a team. Doing some of the things I love is why I'm so excited to join them and start helping them on projects.
Excellent. So just a couple of last questions. So what's one thing as the year kind of turns over, as we're speaking, what's the one thing you're looking forward to next year?
I think one of the things I'm looking forward to most next year is, just continuing to refine my approach to working with helping small companies, getting more into working with ASTM Wohlers on exciting projects, and then hopefully finding a little more time to engage in America Makes and the mission for America Makes. We didn't really talk about that one too much at this point, but I did spend a lot of time being involved in America Makes when I was at Northrop. I spent time leading the design swim lane working group and being involved in the leadership team at the roadmap advisory group level for many years, over 5 years. And while I didn't have a lot of time to do it this year, I'm hopefully going to engage in either America Makes programs or the America Makes mission in some way next year. So I was kind of setting that as one of my goals, is to do more with and for America Makes next year.
Yeah, and I also want to thank you too. I mean, you were one of the big reasons we got our footing in America Makes 8-9 years ago with our first project. So thank you for that, and kind of help one of your early small businesses that you helped kind of get in the door there. So we've always been appreciative of that and all the support you've given on that front. So
yeah.
So as we kind of conclude, last question, more of a fun one. So we can kind of compile a 3 Degrees discussions book list, reading list, general knowledge information list for some of our listeners before the end of the year. We'll be posting that soon. But what would be your contribution? Is there a book that you've enjoyed reading? Is there a podcast you like? Is there a paper that you always find instrumental? It doesn't have to be additive, can be whatever you want. How to the best rotisserie chicken you've ever made, or best smoked brisket, whatever it could be. So
I'll give you one that's a little more connected to the work I've done, but it's still a fun, actually, science fiction read. So one of the really cool projects I got to do towards the end of my Northrop tenure was kind of lead a systems engineering, like, concept development study about building a train on the moon. And there's some presentations out there that you can find. It was a DARPA-funded project under the Luna 10 program. But interestingly enough, the program manager on the DARPA side of the Luna 10 program, Dr. Michael Nayak, is actually also an author. And so he released his first novel, shortly thereafter in this timeline arena of the Luna 10 program, called Symbiote. And it's out. You can go find a copy of it on Amazon or other websites and actually read it. It's a good work. It's a good read. I liked it. And the sequel to it, I think, is coming out shortly. So I'm looking forward to reading that when it comes out.
Excellent. I'll take you up on that. So, Steven, really appreciate the time. Best of luck as things continue to move forward and upward for you, and looking forward to kind of continue to collaborate around the industry.
Yeah, looking forward to it, Mike. Thank you.